So 6-3 logs and log functions. What I want you to do is exploration number 1 with your groupies right now, please. Make sure you read the essential question and this information up above to help you out. All right, let's see how we're doing. Here we go. Everyone's tension up here. Part A. 2 to the third power is 8. Okay? You can write it in log form. 3 equals log base 2 of 8.
Cool.
Okay? How many of you got the 3? How many got this? Okay, so that goes back to what this said up here, right? How many read that? So if f of x equals b to the x, so one thing that might be helpful is if you think of that as y equals b to the power of x. B, we're going to call base. Our base raised to a power. We could then write that in the form of y equals log base b of x. Now, technically, we want to use a different variable, like we call this y sub 1 and y sub 2 here. Okay? But y equals log base b of x. So what ends up happening, if you think of it this way, this base, if you're trying to tie this to your previous learning, this is the best way I found students understand this. This technically, mathematically, I guess like you might have some teachers argue with you on this, but I find students learn it well like this, so I'm going to explain it like this. You're bringing this 2 over here. Right? You're used to doing that to get a variable by itself. When you do that, that x becomes big, and that 2 becomes small. Now, that is not very mathematical. That is me just giving you a quick way of remembering. Okay, if you look for the book to say, hey, when you bring the 2 over, the x becomes big, and the y, that's not going to be what they say. Okay? But that's what's happening. This base becomes that base. We read this as log base 2 of 8. Tell your neighbor how we read this.
Log base 2 of 8.
Now, for those of you that just stopped paying attention, even for like 10 seconds, and you missed how you read that, you just missed a key thing that you didn't know. So once again, tell your neighbor how you say that.
Log base 2 of 8.
Yes. Matt. That's what x is. You would say 3 equals log base 2 of 8. Yeah. Yes?
Why does the equation switch between the essential question paragraph and the word with your partner? The first one says g of x equals log b to the x, or times x, and the other one is log b times y.
Because if you notice here, when we went from here to here, we brought the x down, so it's more accurate in this format. It's a little more confusing in the format they used up here, and that's why I had said you had to change the variable, because technically these two are not the same variable that they use. So the way they wrote it up here is a bit confusing. So that's why I tried to write it like that, and I would think of it more in that format. Okay? So if you're thinking it as b to the power of x equals y, that would become that. Okay? That's a very good question. Yeah, they're very algebraic up here in this explanation. Okay? I would think of it as, just learning it, I would think of it in this format. The b's and the y's and the x's are all the same here. Okay? So this one, 3 squared is 9. Okay? So I could think of that as log base, the base is 3. So log base 3 of 9 equals 2. So what's the key thing that we keep focusing on? The base, right? It's all about the base.
No.
Okay?
Wow.
Letter C.
Wow.
Hey, seriously, what is the base? Base is 4. The base moves over. It's log base 4 of 2 equals 1/2, or x. Okay? How do you think you're getting it? The key thing to begin with is just being able to rewrite it. Okay, being able to relate the two. Letter D, it's a 5 to the 0 power. If you put first power, you fell into the trap. Okay, 5 to the 0, which gives you log base 5 of 1, when we move that 5 over, equals 0. Yeah? You have to keep the 1, yeah. Yeah, that's a good question. You can't just say log base 5 and say, what's the answer? That's like me saying, hey, what's the answer? You'd be like, well, it's pretty radical. I mean, other than that, I don't know. Okay? There's no mathematical, that's like, this doesn't work. You're missing a thing. Okay? It's like trying to drive a car without an engine. It's tough. Unless you have a bunch of friends. Yes. Don't do that either. Okay, let's finish these up. X to the negative first. Do you drive cars?
I can't drive.
Oh, that's good. And letter F. 2/3. Now, please note on E and F, those are two kind of different types of problems. I want to focus in on E first. Know how I wrote that? That's 5 to the power of x equals 1/5, and 1/5 in terms of base 5. So you've got to get in the habit of thinking, okay, base 5, well, the 5's on the bottom. That means it's a negative exponent. 5 to the first. Thank you. So 5 to the power of x equals 5 to the negative first, meaning x equals negative 1. Okay? Since your bases are the same, those two pieces are equal. Okay, and you're going to see that a lot. More specifically, like on letter F here, you could think, well, 8 to the power of x equals 4. Let's see if I can get that there. 8 to the power of x equals 4. You say, well, I know that this is a base 2. It's also 4 can be written as base 4. Knock it off. Thank you. 4 can be written as base 4. It can also be written as base 2. Okay, so this is 2 squared. 8 can be written as base 2. Can it be written as base 4? No, not in a perfect base 4, meaning 4 to the first, 4 to the second. Right? 4 to the second is 16. So since it can be written as base 2, that's 2 to the third. And that can be written as base 2, that's 2 to the second. Write them both as base 2. So 2 to the third raised to the power of x equals 4 or equals 2 squared. Now we set, since we have a common base, our exponents are equal. 3x equals 2. So x equals 2/3. Okay? So that's kind of the work I've shown on this right here. Now, how many understood that? Okay? What are questions that you have right now? Clarifying questions, because all of that should have been brand new to you. Autumn. It is possible to do them on calculators. I will tell you the log you see on your calculator is base 10. So this is base 8. There is a place on the calculator where you can use different bases, but I also tell you that you won't be able to use your calculator on a lot of your tests and quizzes with logs on them. Yes? Right, and once again, pause before everyone grabs their calculator. If you use your calculator to do these, I promise you will fail your test. Because when I say you're not using a graphing calculator, I mean you are not using a graphing calculator on your quiz and your test. Make sure you learn to do these by hand. Okay? Hey, and don't be the student that's done. Every year I say the same thing, and I have 1 or 2 students test me on it. Okay? It's bad for them. Doesn't hurt me. Like, I'm still here teaching. All right? They might be still in trig, but I don't know. Matt.
So in the essential question where it says the inverse function g of x equals log b of x, why did we change it to x equals log b of y?
We had that question a while ago. Okay? And the answer I gave is that this right here, this f of x and this g of x are two different values of y. Okay, so it's kind of confusing the way they wrote it up here. I agree with that. So I would focus more in on what we talked about right here. This makes more sense. Okay, at least just learning it. This is very, I mean, this is true. It's just very mathematical in the way they wrote it.
So are we just like finding the inverse of the inverse to find the original but written in log form?
Here. Yes. Okay. All right. I want to go ahead and take a look at exploration 2. All right. Bottom of the page there. Yeah, Sylvia.
Just really quick, is the only way to solve algebraically for that to the power of x by making the bases equal?
Yes. Yeah. Very good. The only way to solve these right now is to make the bases equal. Yeah.
You use the old base or the new base? Or do you have to say that I need 2 in the logistic equation part?
In this one?
Yeah, do you have to graph them?
No, you would want to use your old base. Another good question there. So when you're rewriting it in log form, you would want to use base 8. Okay? So you go from based on what you have here, and then you could substitute the x being 2/3. Good. Any other questions on those before we go on to the next? All right, exploration number 2. Give it a go. Okay, for those of you that are struggling, here's your hint. Hey, here's your hint. Remember that if you have x, or excuse me, let's go with y first. If you have y equals b to the power of x, the inverse of that is y equal, or excuse me, I keep doing that, x equals log base b to the power of y. What do you know about inverses? Good. You switch the x's and y's. If something's an inverse, x's and y values trade spots. Okay? Now, use that information to help you fill out your tables.
Or you can do it a different way.
What do we do? Good. All right. I really think the easiest way is to just switch your x and y values, but there are other ways to do it. Rachel and I were just talking about them, but okay.
So you see how this is the little 2? So you take this and put that in there, so you see
All right. So 2 to the negative second is 1/4, 2 to the negative first 1/2, and we keep going through there, and then since they're inverses, we just switch x and y. So -1 is now down here, and 1/2 is now up there. Okay. If you graphed them, those should be a reflection over the y equals x. Okay. With that being said, I want you to do exploration 2, top of the next page.
Roar.
Okay, so first, hey, our table should have 1/10 or 1/100th, 1/10, 1 and 10 and 100. Since functions are inverses, they just switch values. Okay? So if I am graphing A, okay, got them both right there. That was the first set. And there is B. Okay, this would be the graph of this table. The first graph I showed you was from our previous table there. But remember, it's a reflection over the y equals x. So one way to graph these, and I'll show you another way, but one way to graph a log function is to graph its inverse. So find the inverse, and then reflect it over the y equals x line. That would be one way. Yeah? So right here. It'll keep getting smaller. It'll get infinitely close. It just won't go over that line. So there will be an arrow here. It'll just ride next to that line forever. Yeah. Okay, other questions? Okay, part of your assignment tonight is going to be, well, hopefully you'll summarize the bottom part of that page. I guess I'm not going to check it, but that's a good way for you to kind of summarize what you learned. I want you to do it later, though. Okay? All right. That is going to be part of our assignment tonight. Okay, so let's take a look at the other stuff you picked up on the way in there.
Woo-hoo!
Here we go.
I don't know why I'm tired.
Okay, without getting too distracted, eyes and ears right here, please. Hey. Jacob, pay attention. Crying out loud. All right. All right, example number 1. Off you go. These are the examples right out of your book, by the way. Why don't you work on those? All right. You haven't done so already, so you know what you got for those first 4.
16 equals 2 to the 4th, and for B, 1 equals 4 to the 0.
Okay, check your work. Hey,
the little number becomes the big number.
You guys, please note that normally you would write this as 2 to the 4th equals 16. I left it in this form just because when I talked to you about it, I said, hey, bring that over here. That base becomes your new big base. Okay? So 2 to the 4th equals 16. We bring this over, 4 to the 0 equals 1. We bring the little base over. As soon as it changes over the equal sign, it changes into special superpowers, just like Ant-Man and Gross. Okay? And you get 12 to the 1st, which is 12. I'm trying to relate it to what you may know. Okay?
That's fantastic. That's fantastic. You're doing a really good job.
Dude, they should have called Ant-Man Logman. That would have been awesome. Okay?
But then everyone would think he's lazy. But then everyone would... Yeah.
Yes?
Do you want us to write it like that?
No, you could write it I would write it normally as 12 to the 1st equals 12. Okay, can I have your attention, please? Hey, any questions on those? Okay, example 2. Okay. See how you did. So now the big switches over and becomes small. The other form of Ant-Man. Log base 5 of 2 equals, or 25 equals 2. Log base 10 of 1/10 equals -1. Now please note, you'll see that I did not put a 10 right here. That is called the common base. Please write that down. If you see log without a base, anytime you just see the word log without a base, that means that is a base 10. So the log you see on your calculator, that word log on the keypad of your TI-84 Cool Guy calculator, that is log base 10. That is functioning in base 10, not any other base. Okay? So when it's base 10, we can just leave the little base off just because we're lazy like that in math. Okay? Bring this over. Log base 8 of 4 equals 2/3, and log base 6 of 1/2 216 equals negative 3. All right. Hey.
Was math created or discovered?
Example 3. Off you go. Okay, let's try one of these. Guys, what I would do first is I'd just say this equals x. Okay? And then I would, if you can't, here's a good rule of thumb. If you can't solve it in log form, write it exponentially. And ask yourself what that answer is. 4 to what power is 64? 4 to the 4 times 4 times 4, which is 3. X equals. That's the answer. Yep. It's not the answer I put on my paper. All right. So if we write this one, awful lot of talking. What is 2/10? How do we write that? 1/5. We could say it's 2/10, which technically is 1/5. So really we say 5 to the power of x is 1/5. That's base 5. It's 5 to the first, but since it's in fraction, it's 5 to the negative first. So x equals negative 1. This one, bring it over. We get 125 equals 1/5 to the power of x. This is base 5. 5 to what power? 5 to the third. This is base 5. 5 to the so what's x equal? Well, 3 equals negative x, so x equals. Okay. Last one. 6 equals, let's bring that over. 36 to the power of x. Base 6. Is this base 6? Yes, sirree. Oops, that's x right there. So 1 equals 2x. So x equals 1/2. Could you have done it a different way? You for sure could have. I'm just trying to show you an algebraic way to do it. Hey, your assignment, listen up. Your assignment is to complete as much of this packet as you can tonight in a half hour's time. Do your best not to use your calculator unless it says to use your calculator.
Like in
We'll
the
pick
next
up there
example?
tomorrow. Okay, so that'd be, yep.